So let us start. A very pleasant evening to all IEEE representatives, exam members of various regions and subsections, faculty from various colleges, branch counselors, student volunteers, and organizing committee of this event. Myself, Dr. Uma Mageshwari, Treasurer, IEEE Bangalore ITS Chapter, and Professor from Amata School of Engineering, Bangalore. Welcome you all to the 25th International Webinar on 5G Technology and Overview. So this day is very special for us. We are conducting 25th International Webinar, and it is organized by IEEE Information Theory Society Bangalore chapter in association with IEEE Bangalore section and IEEE Mysore subsection. Let me start the event by briefing you about IEEE. IEEE Institute of Electrical and Electronics Engineers is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire a global community to innovate for a better tomorrow through highly cited publications, conferences, technology standards, and professional or educational activities. IEEE is the trusted voice for engineering, computing, and technology information around the globe. About IEEE Information Theory Society, we shortly call this chapter as ITS. And ITS is a leading technological society that focus on the processing, transmission, storage, and use of information, as well as the foundation of the communication process. IEEE Information Theory Society membership enables an individual to stay connected up to in the current technology and ensures one is in touch with peers. I request Dr. Jagannathan, Secretary-elect, IEEE ITS, Senior Solution Architect, HP Bangalore, to welcome and introduce our today's speaker, Mr. Jishnu Aravindakshan, Principal Project Architect, Tejas Networks, Bangalore. Over to Dr. Jagannathan.
Thank you, madam. Am I audible, madam?
Yes,
I'm
sir.
audible. Yeah, yes, madam. So it's a very privilege for introducing our today's speaker, Jishnu Aravindakshan. Welcome, sir. Welcome, everybody. Jishnu Aravindakshan is a principal architect at CTO Office of Tejas Networks India Limited, having 17 years of experience in telecom. He obtained a bachelor's degree BTech in ECE from NIT Calicut in 2001 and master's from IISc Bangalore in 2004. Subsequently, he joined the Tejas network and he is responsible for deciding the long-term roadmap of the company. He represents Tejas at ITU TSG 515 and has contributed towards the development of ITU TG 803.2 and MPLS TP standards. His present interests include 5G, advanced evolution, IoT, and network slicing. He is actively involved in 5G standardization through TDSI, Telecom Standards Development Society of India, at ITUR WP 5D. And as an individual member at 3GPP, ran SA2, he was closely involved in the design of 3G, 4G backhaul architecture with major Indian international operators. He successfully represented India and TSDSI during IMT 2020 standardization activity for inclusion of LMLC as a 5G evolution configuration in rural EMBB. He was the founding chairman of Optical Access Transport Study Group in TSDSI, which developed CPRI frontal standard. Later, he continued as the vice chairman of this same study group at SGN and continued efforts from TSDSI for inclusion of 5G radio interface technology, RIT, or also called a 5GI from India, ITU or IMT 2020. So he has filed 17 patents, was awarded the Best Paper Award in 2006 from IETE. He has edited the Springer CSI Transaction ICT on a special issue of Wireless in the Future as a guest editor in 2019. So welcome you, sir, once again. Thank you, madam. Back to you.
Thank you, Dr. Jagannathan. We are very excited to see the profile of the speaker. Now, may I have the privilege of inviting Mr. Jishnu to address the gathering. Over to Mr. Jishnu.
Thank you. Let me share the screen.
Yes, sir. Yeah, it is visible.
Okay, it's audible as well, right? I am clear.
Yes, yes. It is visible as well as audible.
Okay, thank you. First of all, I would like to thank IEEE ITS Bangalore chapter, and good to know that this is your Silver Jubilee webinar. I would like to thank Professor Parameshachari, who invited me for this event. I would like to thank Uma and for coordinating this event and the other coordinators who are involved with it. I intend to cover the 5G RAN aspect in the talk. We will not be covering too much of the core aspect. And I'm assuming that most of the participants here would have basic understanding of 4G. So this is over and above what 4G has done. Please feel free to ask any questions over chat box, and I will respond at the end of the talk. Okay, so what I intend to do is, coming from an industry, we start any work with knowing the market. So I will just give you a broad idea of what is happening in the market. After that, I will get into technology. I'll be telling like what are the key differences which happened over 4G protocols, in the sense 4G standards, and over that. So as I told you earlier, I'm assuming that most of you are aware about 4G standards. And last but not the least, India has contributed towards 5G as part of the IMT 2020 process. So we are the 5 countries which have seriously contributed. We have a smaller part compared to other countries, but it's a significant part of contribution, which I will explain in slightly more detail. On the 5G market, you can see that this is a report from Omdia. So you can see the 2G, 3G, which has been there and which most of us has more or less discontinued, other than to get the SMS, is actually significantly supposed to go down, and few of them may be used for maybe machine-to-machine communication, but most of our phones would be either 4G or 5G. You can see a significant growth in 5G, supposed to become a 26 billion market just on the RAN part of it. And you can see already the launches has happened. So this is slightly dated. What I understand is around 195 networks, or as per Ookla study, the speed test study, it's around 195 network. As per GSMA, around 224 networks are live. Many of them are still in the trial stage, so it's not commercially launched. So that's where 5G is as on date. So the 5G eventually would grow at the expense of 4G, and as you can see, most of the newer phones are coming with 5G already. You would have a lot more of those happening over time. What are the use cases? Is it still the mobile broadband, which we have been used to? No, there is one significant use case which has already launched, which is fixed wireless access. This was identified as a major use case for millimeter wave. I will cover that millimeter wave in slightly more detail later. But the key idea was that how do you see the real problem, if you see in any communication technology, is the last mile connectivity. And this is true whether it's communication or whether it's transportation. The real problem is how do you reach from metro station to your home or to your office. So that last mile always remains a problem, whether it is in transportation or in communication. So one of the idea was that why don't we use 5G, because we are getting almost fiber-like speed to cover the last mile. So that's one application which has seen significant deployments, initially on millimeter wave, now even in sub-6 gigahertz band, or what's called the FR1 band. And then from a technology perspective, the release 17 is about to complete. Even the meeting as we speak, the release 17 is happening. Release 18 work has started in SA2, and subsequently it will start in the other band side of it as well, most probably by the next meeting time. So I would be covering mostly the release 15 and 16. 17 is, I'll just indicate one or two things in release 17, but mostly about release 15, 16, which actually constitutes the major part of the 5G deployments which are happening. Just to give a idea of what happens, I hope most of you would be knowing it, but I'm just giving a background to this. So all of us use mobile phones and mostly smartphones, or which has either an LTE connection or a Wi-Fi connection. Wi-Fi we also use in our homes and offices. So you might have seen most of the Wi-Fi now coming up are either Wi-Fi 5, and soon you will have 6, 6E, and 7 coming up. These are then connected. The phones are connected using 2G, 3G. 3G is more or less switched off in most countries, and even in India. The BSNL may also switch it off soon. So basically, you will have 2G, 4G, and 5G handsets, which would be connected mostly in sub-3 gigahertz band till now. But with 5G coming in, you will be using higher frequencies. These are backhauled using what is called mobile microwave backhaul. These are in centimeter wave. So the small cell, which I have shown here, it can also be a 5G small cell. This can be either connected over fiber or can be connected using microwave backhaul. This then connects to in the same tower, you will have microwave antennas to connect to the backhaul. There is also a technology called IAB, Integrated Access and Backhaul, which came in release 15. So you can even discontinue a proprietary microwave technology and move into using 3GPP based technology even for backhaul. So that I'm not covering in detail, but that's another application which has come up. So the microwave backhaul is also no more proprietary. So we usually radiate in licensed band. The Wi-Fi, as you know, are mostly in unlicensed band, and these are not unlicensed band are not good for high-speed scenarios, and over time the quality degrades because there are multiple users using the same band. Technology-wise, both of them use OFDM and OFDMA for multiple access. But there are major differences in the subcarrier spacing. So the subcarrier spacing you would have seen in LTE is 15 kilohertz. I will discuss further in detail on it. It has changed further in 4G. So these are but in kilohertz range. So these are all narrowband signal from a user perspective. So this has a significant difference from a wideband signal, especially from a propagation characteristics and fading, etc. So that's the key difference. So that's why LTE would be much more spectrally efficient than Wi-Fi. And then it's all in licensed band. So I am allowed to radiate at a higher power. In unlicensed band, I have restrictions on my ARP. So that would mean that my coverage will be always less with Wi-Fi, but would be very larger in 4G and 5G. Again, this is subjected to the propagation characteristics, in the sense if you are using higher frequencies, the coverage range also comes down. In addition, if you have fiber connectivity to your home or offices, they are connected using Ethernet links or what's called the GPON link. At your home, it will be mostly PON link, which is passive optical network. So you usually have an OLT at the customer end, at the ONT at the customer end, and then at the head office or something where you have the OLTs. All of this then connects using a backhaul transport network. These are all mostly moving to WDM along with IP. The transport as such is WDM, and then endpoints are IP based. This connects then to a core. In case of 4G, it was EPC. Even in 5G, NSA option, the core remains EPC. Only when you move to something called a standalone option, you have a new core, which is called 5G core. For OLT management, you have something called BNG. For Wi-Fi core aspect, you have wireless access controller, WAC. So this together forms the today's communication network, which we use in multiple ways, whether in our office or in colleges. And this is how the end-to-end network are built, and basically you get internet connectivity through this network. 5G, what it changes first is that it's becoming more softwareized as we go into 5G. We are trying to use as much as possible standard CORD server, but this is not always possible, especially on radio side where physical layer is involved. Still, it's not possible. Even DU, some aspect of it, if you really want to scale, still we can't use a general CORD server. All the component, you might have seen or read news around AMD buying Xilinx. Similarly, Intel buying Altera. So you are seeing FPGA being part of, hopefully in the next version of the chipset. You will have a part of your chipset which also include FPGA, which is a hardware block which you can program. So that would allow you to at least hive off some part of your processing into the FPGA, especially wherever you need hardware acceleration like LDPC coding, etc., which needs to be done on a FPGA type thing, and it's very difficult to do on x86 processor or an ARM processor. Those could be hived off into an FPGA, and you can basically run it much faster than what processor would. And it would be much lower power consuming if you use the appropriate process technology. So the process not the state of art, especially for the FPGA portion of it. But what set companies are that they are working towards making it very power efficient. So hopefully we will see a significant reduction in power consumption by this device. And all of us can migrate into a completely CORDS-based option, even for DU. But EPC, whether it was the core, the 5G core, or it's all migrating CORD server. So all you need is a data center with virtualization where you can run it. You will continue to get internet. That's the good part, unless like in Russia, somebody passes it. Otherwise, you should be able to get an internet connection. Beyond that, what do you get? You would get what is called a broadband slice or an EMBB slice. Here, the key idea here is that you would be getting a committed rate of bandwidth, unlike what you get today, where you can see a very big variation in your data rate. The EMBB option allows end-to-end QoS, whereby you should be able to get committed rates. This is can be offered as a specialized service. In addition, you would be able to get activity in high-speed train. During the Japan Olympics, I think they launched the 500 kilometer per hour train. So even the key idea was that to cover that, you needed a better technology, especially because your Doppler would change at higher speeds. So 5G cater for that application. Other slice, which is basically a slice, could be a set of frequency range which can be used specially for that particular application, and then the back end you have appropriate QoS built into it. On the MMTC slide or the IoT, which is popular name is IoT, and in communication it's called massive machine type communication. You would have V2X, and hopefully when you buy your Tesla, when you are running in completely automated mode, you would be connected to the 5G network. So this is not mandatory. There are other ways to communicate, whereby without actually using 5G, also you can do a V2X communication. but this is one of the technology which would allow you to have a like full, not just in India, but global coverage across multiple sectors, etc. The last, but the most important application, which would most probably differentiate 5G from 4G, is related to low latency application and to bring in reliability. So one of the aspects which if you have been using any connectivity at your offices, is the reliability. There is something called a 50 millisecond, which is like a number which nobody in the optical domain, etc., even think of. Like the bare minimum we have to meet is a 50 millisecond protection switchover. These are not possible in radio today because you basically do what is called a break before make. So you break the connection, connect to a different cell, and then make the other connectivity. So that is not a very reliable way to do it. So reliability is much lower in wireless compared to wireline. So 5G is making an effort to bring in reliability. This is still work in progress. So when release 15 was done, neither the MMTC or the URLLC was completely defined. Release 16 and 17 plus is working towards it. Release 17 is still working on the latency part of it. And last but not the least, if you are willing to drill a hole on your brain, you can insert an Neuralink so that you don't even have to move your finger when you are operating your next generations of phone. So let's see whether people are excited to do that. So that again needs very low latency because you are more like you just have to think to move your screen or to the next page or whatever. So how does it all start? How does a technology, what we call the 5G or 5G advanced, which is supposed to come soon, how does it all start? It all starts with ITUR setting up a target. These are targets which has to be met by any technology standardized SDO. SDO here means Standard Development Organization. So India has our own SDO. It's called TSDSI, which is what worked in that 5GI standardization. The LMLC is a requirement. So the requirements, usually you have to work in ITUR to get the requirements in. So you can see the broad requirements on this might be a web which you might have seen many number of times in different 5G talk. You are supposed to improve spectral efficiency 3 times, user experience data right 10 times, which has been consistently, if you see the technology, whether it's 2G to 3G to 4G, it has been happening. I see some Rashid Ali is requesting to update the shared content. Is there any? Okay, sorry. Yeah. Hope I am audible and.
Yes, sir. You are audible. Your presentation is visible.
Okay. So basically, yeah, the peak data rate is supposed to go up by a factor of 20. So you can have 20 Gbps. This is subjected to you getting enough bandwidth. So you see 5G is designed to handle up to 6.4 gigahertz of bandwidth, assuming that you can do 16 carrier aggregation, 16 component carriers you can use. And then each of them can do up to 400 megahertz. So that's quite large. So eventually there is effort to further scale it up. But yeah, we are not expecting any operator to get 6.4 gigahertz. But the higher the bandwidth, so that's purely from a Shannon thing. If you get more bandwidth, you will be able to communicate, you will have a higher capacity. So the target was kept as 20 Gbps. Area traffic capacity is a new parameter. This is basically because we are using millimeter waves. How do you ensure that you actually are able to send larger amount of data within a given area? That's actually a performance improvement of 100 times. Network efficiency is supposed to be 100x. This is some parameter which is a target and very difficult to measure unless we see a deployment. But it all depends on the MIMO which you are using. So if you are using higher MIMO and the frequencies, all of this has an impact. The most inefficient part of radio communication is the power amplifier. So, so it depends on the power at which you operate, etc. So this is some target which I think even in release 17 we are struggling to meet, and it has to do with an implementation rather than a technology asset. So this is one aspect which is for further improvement in even maybe a release 18 and further. Connection density also is supposed to go up by a factor of 10. Each of us are supposed to have 10 devices rather than one. So that's how it is architected. Latencies is supposed to come to 1 millisecond, but it's a tough ask. I will explain how progressively it will come down, but it's still not 1 millisecond in actual field deployments. And as I mentioned, it's supposed to handle trains which are running at 500 kilometers per hour compared to 350 kilometers per hour in the 4G case. How do I change the thing with another on? Okay, so what's 5G? 5G is actually 3GPP release 15. 3GPP itself is a consortium of 7 standard developing organizations. One of them is TSDSI, which is an Indian standard development organization, which is started by DOT. So we have been using TSDSI to contribute towards most of the Indian companies are working through TSDSI to contribute to 3GPP. 3GPP as such is not a standard development organization. It's a consortium of all the SDOs. So once 3GPP makes a standard, all of the individual SDOs has to adopt it. TSDSI also has adopted it. And when TSDSI adopted it, we also wanted to do our own standard, which are called 5GA, which I'll explain later. So the first thing started as release 15, but before even release 15 got standardized, some of the operators, especially Verizon in US, went ahead and implemented a pre-standard version of it. South Korea also did a pre-standard version of it. Release 15 is the first formal release, which any vendor which implements release 15 becomes 3GPP, becomes a 5G vendor. So this is the first standard, and again you can see like what happens with many software releases. You had an early drop, a main drop, and a late drop. The early drop is basically to support NSA, the non-standalone option. The main drop went ahead and standardized the standalone option, and the late drop went ahead and standardized multiple different migration options. So these options are like, so the NSA option is basically if you have, most of the handset today are NSA. Some newer handset comes with both option, NSA and SA. So all of you should basically check this because all the brownfield operators would like to start with the NSA option. The NSA option reuses the existing 4G code and with some software enhancement. But in SA, it's mostly used by greenfield operators. Very few of them are there because most of the 5G operators today are migrating or enhancing their 4G with 5G. So that's NSA option, which most of the phones support it, but SA options, very few phones support it and very few networks also support it. So that came in 2018. And the last options are, there are multiple ways to migrate from NSA to SA. So that's are the different options. You can further read it, the 3GPP standard. Then it came to release 16. Here you can see the initial work on URLLC enhancement happened, the operating of NR in unlicensed band. So you potentially have a competition between Wi-Fi and NR. NR is the 5G physical layer standard. It's called New Radio. We use quite a number of terminology. So, yeah, so in wireless compared to what we have in wireline. So NR is not new radio and U means unlicensed. So new radio, unlicensed, it's possible to do it. In LTE, there was something called an LA option. It's a license assisted option, whereby you always needed a primary carrier to support you to migrate into LTE LA. In NR, it's a standalone option. You can even have a standalone NR running in unlicensed band, and it can compete or collaborate or whatever you can say. It also does the listen before talk in the unlicensed spectrum, and hence you have a single technology which can operate both in licensed and unlicensed band. The 5G efficiency has been improved. There is something which I mentioned, integrated access backhaul. So you potentially don't need a microwave backhaul. You can use frequencies. These are basically initially the idea is to use higher frequency bands, E band and V band, for doing the backhaul. The E band and V band are 60 gigahertz and 70 gigahertz. So these are used for backhaul because we need larger backhaul bandwidth to do 5G. So that's only possible if you move into higher frequency bands. So that's the potential. That's what is being thought about. In India also, that discussion is ongoing. It's not very clear whether it will be licensed, semi-licensed, or unlicensed. But as a technology, 5G allows all the three options, so there is no issue on supporting. There are other changes to support other applications like FRMCS. This is related for railways to upgrade. So many of those, what you call the GCS, group calling services, so which railway need. So it's basically if the driver speaks, multiple station masters can listen to it. So such services are provided. So how do you initially see, and what is the potential deployment options? So the 4G EPC continues to be because many of the operators have just installed 4G. They don't want to EPC. They don't want to migrate out of it soon. So EPC would continue to be 4G EPC based. You will have 4G base station, and same 4G base station may have a 5G macro cell as well. And you can have multiple 5G small cells. Or you can have even 5G macros at a higher frequencies operating, but the coverage would reduce. So within a 4G coverage area, you can have multiple 5G hotspots. So this is like, if you want to see it, it's like a Wi-Fi hotspot. It will have much larger coverage because you have higher radiated power within a 4G coverage. So in the NSA option, what happens is you usually have a dual RF chain. The one chain would connect to 4G. So most of the initial phones would continue to use VoLTE for your voice calls. So there is only in release 16 the voice over NR got standardized. But otherwise, so even if you have a 5G phone, your voice would continue to be over 4G. All your control signals would go through 4G. And then 5G base station in turn can talk to 4G. So there are options called option 3. Within 3, there is 3, 3A, and 3X. Slight variations to it. And that basically would indicate how the 4G and 5G base stations would communicate between each other using the X2 and XN interface. And it mostly would be deployed in urban area initially. So we are seeing initial deployments in dense urban where already the capacity problems have happened. Most likely in India, we have already, as most of us use mobile broadband rather than fixed broadband, we would hit this problem much earlier than many developed countries. So dense urban should see a lot of 5G deployments. And we use what is called an ENDC. ENDC here means EUTRAN is what was called for the 4G, and NR is the radio for 5G. When you say ENDC, it means that UTRAN is the primary controller and NR is the secondary controller. So the control is with UTRAN, which is LTE, and data would be on NR. So the idea here is that whenever you feel that you need an extra boost to your download, you basically connect to a 5G, download your content, and then go back to your 4G. So that's how the initial deployments are happening. Eventually, we'll all migrate to what is called an SA mode, where we'll have our own, that's a separate 5G core, which would come up in addition to EPC. There are multiple options. You can continue with having EPC and 5G, EPC operating 4G, or you can eventually migrate even 4G base station to 5G using an upgrade to the 4G software. It will then be called NGENB. Then it can connect to the 5G core. So there are multiple options. So that was the option 4, etc., which I not explain. So that will depend on the operator's decision. So you can, as a handset, what change you would see is that you can either connect to 4G as 4G, connecting to an EPC, or 5G and connect to 5G core. So till you have an SA phone, you will not be able to connect to a 5G core. Other thing, why do you need a 5G core? The key motivation here is that you are moving to away from signaling protocols to HTTP2 and JSON in 5G core. We have vendor agnostic API, so you create much better functions, applications on top of it. You can have application functions which are well defined. Where, say, one of the key applications which people are looking for is, if suppose my network quality is bad, can I reduce the quality of my video dynamically as and when the quality of network goes bad, so that the user don't even feel that that the network is bad, or this information can be provided to, say, a Google, or even in this case WebEx, and they can use that information to accordingly change the resolution to each of the user. This creates slicing. As I mentioned, we need at least 3 slice, EMBB, URLLC, and MMTC slice. There are 4 slices defined right now. You can have more slices if you want. So this would allow separate slices to be provided for different operators. You can have in India, say for example, Toyota using a separate slice, Maruti Suzuki using a separate, to run the network of all the cars, all the V2X cars. So this could be offered as a service whereby they slice a part of the spectrum and provide it to the to some VNO type guy. It's a virtual network operator who just uses the slice to provide specific applications. And say for example, if you have MMTC, you would have to support many cars at the same time. So accordingly, you would give a slice where they can instantiate an MMTC application and run multiple V2X session on top of it. There are service-based architecture where you have NRF, NEF. I'm not covering this in detail as I mentioned. You can read through 3GPP if you are interested to know more of it. The control and the user plane segregation has been done here. So the control, which is basically SMF, is session management function, includes the control portion of S gateway, P gateway, MME, which was there in 4G. AMF is the access management function, and the AUSF is the authentication function. Then there is a user plane function. So the user plane function is purely handling the data plane. So you can independently scale your user plane as well as your control separately. So top level, these are the changes. The E node B will be called as G node B. E node B, if it connects to a 5G core, would be called as NGNB. The S1 interface, which you use to connect to MME and S gateway, the S1U and S1C, is migrated to NG interface, the next generation interface, where you can connect to the MF and UPF. So the MME and S gateway, you can see, is roughly called MF and UPF. The portion which includes GNB and NG-ENB is called NG-RAN. Earlier it was called UTRAN, which includes ENB and even the IEEE cells, the E node B and relay node, etc., were part of what is called the EU TRAN, and the other portion was called the EPC. So that architecture is moving to what is called an NG-RAN and 5GC. And the interfaces, these are all virtual interfaces, also changing. You can read it further on 38300 if you want to. There is a newer version of it. This is a slightly older version which I'm referring. So let's start with the frame. What has changed? So it continues to be OFDM based waveform in 5G as well. So there is no big change as such between 4G and 5G from a waveform in the downlinks. Same OFDM. In uplink there is a change. Basically, what has happened is you can either use the CP-OFDM or DFTS OFDM. So if you remember in 4G, you could use only DFTS OFDM. Here, the idea is use mostly CP OFDM. Whenever you are, both are mandatory, CP OFDM and DFTS OFDM. DFTS OFDM, if you are not in a good coverage area, then you can use DFTS OFDM. And PRAJ, which is the random access part, still use DFTS OFDM. So the CPO FDM only allows you to have MIMO connectivity on even in the handset. If you are using DFT SOFDM, you will have only single layer. Single layer means you will have you will not have a MIMO capability on your phone. With CPO FDM, you can have capability of having MIMO on your phone. So each frame, if you see the structure, it remains similar to what you have in LTE. Radio frame is 10 milliseconds. Each subframe is 1 millisecond. You have slots, and then slots. The big change between 4G and 5G is slot is not like fixed. Slot is like slightly. Slot is defined as a millisecond, but you can see that number of symbols. Each symbol is like an OFDM symbol. Would vary in the sense you can have say for example 1 millisecond would be your slot size in case of 15 kilohertz. It comes down to as low as 0.62, 0.0625, 62 nanosecond if it's 240 kilohertz. So the slot is reducing. If you see 4G, it was 32 nanosecond for one of those symbol. But here, if you are using for 240 kilohertz as the subcarrier spacing, you can have 62 nanosecond as just a slot itself. You can have much lower things there. So the idea here is that this is what is called the subcarrier space, SCS, subcarrier spacing. You can have different subcarrier spacing from 15 all the way to 40 kilohertz 5G. If you remember 4G, we had only 15 kilohertz as the subcarrier spacing. The additional thing was that we were using mostly 2048 as your FFT. We will move to 4096 in 5G from a DFT the FFT perspective. So your FFT was 2048. In 4G, we are going to 4096 5G. And the idea, why do you need so many subcarrier spacing? Why should we go to 240 kilohertz? We are even allowed to now work in frequencies all the way up to 71 gigahertz. So that means if you are going to say 71 gigahertz and you are still sticking to your 4096 as your DFT, obviously your subcarrier spacing has to go up. Why 4096? Can't we increase the DFT size? That's limitation with the devices which you have in the market, and over time that would also change. So with that, so that means for higher frequency band, we would have to use larger subcarrier spacing. That's the flexibility which was brought in 5G, and you can straight away see that if I use a bigger subcarrier spacing, if it is 240 kilohertz, my latency also comes down. That's the first concept of reducing the latency in 5G. The second concept is you have a concept called mini slot. So earlier, always 14 symbols constituted a slot, and that means you can only schedule within a slot, can't schedule lower. In 5G, you can even do scheduling per mini slot. So that further reduces the latency. As I mentioned, there are 14 symbols which forms a slot, and your latency straight away comes down by this factor 2 power n. N is n. So basically, your subcarrier spacing you can see is 15 into 2 raised to n is how it has been allotted. So different subcarrier spacings are there up to 240 kilohertz. But it's not like all of them are used. I will explain in. And then supports both analog and digital beamforming. So it also supports unlicensed spectra. So there is an option to do a listen before talk. That's the reason we need a mini slot, because otherwise you would, by the time if you have to wait for a full slot, and suppose the slot is 1 millisecond, some other person may take that slot already, and then you would be stuck. You will never be able to connect. So especially in an unlicensed scenario. So the ability to schedule within a mini slot is important even from an unlicensed node. Other change which has happened is you have the same synchronization. So once initially the first time when you switch on your phone, you basically have to get yourself synchronized. These are provided by primary synchronization signal PSS and secondary synchronization signal. Then you have a broadcast channel from which you basically would get the information where to look for different things. And then PBSCH also takes care of the DMRS. So as you know, like in 4G, we do coherent demodulation. So if you have coherent demodulation, you should get a view of the channel. Otherwise, you are not able to demodulate. So this is just from because many of you are from a vehicular background. So it's like if I have to start if I have to go from say Bangalore to your Mysore chapter, one way is that I can just look into the Google map, figure out which are the different paths and which of them has least amount of traffic, and then use the path which is the least amount of traffic. This is roughly the idea which we do in wireless as well. And for that, we use what is called a DMRS for the coherent demodulation, whereby we send the signal. It's a pilot signal, well defined. Everything is it's easy to decode and all that stuff. Use that to estimate your channel, and all the scheduling is based on that. Scheduler as such is not defined in the standard. So basically, you use this information, and it's up to you to decide. Same as what we use with Google Map. Even if we find two paths, and if we find that some path has lesser traffic, but for some reason you want to use still the older path with larger traffic, assuming that traffic may move faster, you are allowed to do it. So same concept applied in 3GPP. But that information on the channel, on the DMRS, is actually part of the PBS. PB here means physical broadcast channel. So this is the broadcast channel, which unlike in 4G, 4G you would have seen that all of this synchronization is at the middle of the carrier frequency. So basically know that all that would come around the middle of the carrier frequency. In 5G, it's not. Each of them can have their own location, and usually it's kept at the start of the frame in the sense. This is basically to support even unlicensed band. And there is a fundamental concept from a radio layer which is different from 4G. We unnecessarily don't want to corrupt or radiate if there are no users, etc. In 4G, we always used to send pilot independent of whether you have user or not. Here we have multiple options where the design itself, it's taken care that I can switch off unnecessary signals if there are not many users. So that's the way, that was the intention to reduce power. So basically, if you don't have user, I can reduce my power, even shut off my complete radio transmission if there are not many users. So with that idea, the synchronization comes right at the start of the signal. You have 576 resource element assigned for PBSCH, and this includes both the DMRS and MIB. MIB is the master information block. So this gives the information where to look for, say, like different aspect of it on the initial part of it. So it has very minimal information in MIB. And then from MIB, you can basically start decoding what is called a secondary information block. That secondary information block gives you more details about the device, etc. So I'm just starting with what was there in 4G and what changed in 5G. So if you see 4G could have operated up to 3.5 gigahertz, but mostly it operated below 3 gigahertz, or the maximum was 2.6 gigahertz. In 5G, we can operate in FR1 and FR2. FR1 is sub 6 gigahertz. FR2 is actually between 24 and 52. It is further being extended to 71. And then the other bands between, so what happens between 6 and 24? Right now, these are being used for microwave backhaul. The idea is eventually, once that is freed up, can also start using 6 to 24, which will be called FR3, or some other for the access purpose. So right now, this is mostly for backhaul purpose. And the idea is FR3 may become part of 5G advanced or even 6G to use those frequency, because the lower the frequency, purely with propagation delay and physics, you will be able to cover a longer distance. So as I mentioned, DF, the waveform allows in the uplink CPO FDM, which is same as the downlink option which was there in 4G. Both of these uplink and downlink is now CPO FDM. Option is there. Modulation, we can go to 256 QAM. Even 4G in the later version, the updated version, has supports 256 QAM. So you can see that there is not a big improvement from a modulation perspective between 4G and 5G. It's almost. And so if you don't get a larger bandwidth, you basically, there would be hardly any difference between a 4G and 5G through what you get on your phone. The big change on coding is that you are moving from turbo coding, which is quite difficult to implement on, and it's very costly if you want to put that way, to implement turbo code. We are moving to LDPC coding for data complexity. We got a new code, polar code in multiple channels, whether it's PC, HDC. So this polar code was something which was basically a political decision rather than a technology decision. But it's useful if it's greater than 12 bit, and then if it is smaller number of bits, you use read modular code. So this is a bit complicated from my coding perspective because it was just turbo coding in 4G. Here we have a mix of coding based on, but for data plane, it's just LDPC, which is where the major amount of processing needs to happen. Subcarrier spacing, we are moving from 15 kilohertz to 15, 30, 60, 120, and 240. You can see that in FR1, certain frequency bands are used, 50, 30, and 60. FR2, you will have 60, 120, and this is basically because, as I mentioned, the FFT size which can be supported is 46. The maximum subcarriers has moved from 1,200 to 3,300. So your number of resource blocks have moved from 100 in 4G to 75, and we are getting efficient. You can see we are using 3,300 subcarriers. And this, so this number is fixed in 5G, 3,300. That's why you can see you can handle, say, 100 megahertz with 30 kilohertz subcarrier spacing for FR1. And in FR2, you can go up to 400 megahertz with a 120 kilohertz subcarrier spacing. SCS is subcarrier spacing. The duplex mode, if you see 4G, had TDD and FDD. India was one of the first country to deploy TDD. And now you can see in 5G, it's mostly TDD because it becomes much efficient to do TDD in higher frequencies. The key reason here is that it's symmetric. So you can get a feed of the uplink and downlink scheduling becomes simpler. So all the higher frequencies are in TDD. But 5G has gone ahead and made it very flexible. So you can, on a per symbol basis, you can decide whether to make it downlink or uplink. So you have 56 formats defined in standard, so that you can change it quite dynamically. So the key idea here is that at millimeter wave, where you may have one or two users, and the user is mostly uploading loading for some reason, you can completely convert the frame into an you can completely change it into 56 into a completely uplink only channel. All this flexible, it's much flexible than you can see 4G. 4G TDD didn't allow at few modes, 6 or 7 of them. Here you can have 56 format of it, and these are also dynamic. Regulatory basis, 4G was mostly SAR. So that SAR limit in India, we have a very strict SAR. It's 1/10 of the global number. But in 5G, we are going to an EARP based as well, especially because higher frequencies, general terminology in EARP mode, and even for unlicensed, it's in EARP. The channel sounding downlink, might have seen in 4G, you have two type of reference signal. One was for a cell-specific reference signal, and the other one was a channel state information. The CSIRS, you need it for per device basis to estimate the channel on a device basis. And the CRS was on a cell level. Here, because we are having beamforming and you have multiple smaller pointed beam, there was no reason for keeping a CRS. So there is only CSIRS. So we are discontinuing CRS in 5G. In 4G, there were two type of frames, type 1 and type 2. Here, there is only one frame. So that's another big difference. We don't have a separate frame type for FDD. Everything looks same. The slot length was 6 or 7 simple in 0.5 millisecond in 4G. Here, I can have 14 symbols per slot, or even something called a mini slot, 2, 4, 7. These are the options given. In 4G, all handset were supposed to implement 20 megahertz of receiver bandwidth. In 5G, that limit has been taken away. So you can have, you can basically inform the bandwidth part using RRC, and then you can adaptively change that bandwidth as well. So you need not be 20 megahertz. The idea here is that if you are using it for MMTC, which may be, say, suppose smart meter, may not need more than a megahertz or less. So you can even inform that through the RRC and then use that and reduce the cost further of the devices. The full duplex was not a possibility in 4G. Here you can even do full duplex, and this is especially used for IAB for the backhaul purpose, where you can both transmit and receive in the same frequency. The retransmission was HARC. The big change from 4G here is we still use HARC, but we have the option of incremental redundancy. Here it means that we can here the big difference is that we are split up the whole transport block into multiple code blocks. So if you want to repeat, you can repeat only the code block, not the full transport block. Transport blocks can be quite large, can be thousands of bits, even like I'll explain it later. It can be large, but then what used to happen in 4G is that you would have to, if one of the transport block is lost, you would have to repeat the entire transport block. Here we don't have to do that. We can repeat only a particular code block which was lost. And the other big thing from a HARC perspective is both uplink and downlink are asynchronous now. In 4G, it was synchronous on the uplink side, which basically meant that you can't reduce latency below 3 milliseconds. Here, that restriction has been taken away. The control channel was always full carrier bandwidth in the 4G case. Here, we go into something called a core set. Core set is the control resource set. So you need not have the full carrier bandwidth for your control channel. So this helps us because you can have one core set associated for certain set of devices, another core set associated with a certain set of devices. There are some specialized things, like core set 0 has a special thing. So so that's separately done. Beamforming was not possible in 4G, very much possible in I'll explain it slightly on what do you mean by beamforming and how it's done. There is slight difference because in higher frequency FR2, you may be using analog. In FR1, it's lower than below 6 gigahertz. You will always be using digital beamforming. Digital beamforming means you will be doing some pre-coding before sending it. So that's possible, but in higher frequency, it's not possible. So whatever beamforming algorithms you have should be able to cater to both of it. So as I mentioned, because I don't have this HARC restriction of it's made asynchronous, I can even send my HARC within 2 symbols later. So that basically means I can really reduce my latency. It's called short PUCCH. So that would allow me to reduce latency quite a bit, even to nanosecond level from a architecture perspective. From a MIMO, you can see again, both of 4G also has been enhanced. So MIMO also, you can see both are same. So both of them support 8-layer in downlink, 4-layer in uplink. So even MIMO has not changed and modulation has not changed. So 4G and 5G would look exactly same from a user perspective if you don't get larger bandwidth. So that's the key here. Initial access, as I mentioned, the whole idea of 5G was to not send unnecessary signal. So SSB, which includes the primary synchronization signal and the broadcast channel, instead of repeating every 5 milliseconds, which happen in 4G, we are repeating it every 20 milliseconds. And we also have a very sparse frequency raster, unlike in 4G, where we more or less had a raster at the center of that band. The coexistence, there was no coexistence of 4G with 3G. 4G was completely brand new technology. In 5G, we are actually having a coexistence with 4G. 5G is as a first step, supposed to use some of the 4G frequencies also. And you could even start with the existing bands, half of it being used for 4G and another half being used for 5G, using this technology called TSS. And then there is the idea here is also that, especially when you are moving to higher frequency, the real problem is on the uplink, which you would be knowing in LTE or 5G case, is because my handset has limits on the radiated power. You have 23 dBm is the upper limit. That is because your SAR and EARP, SAR limit, etc., doesn't allow you to scale it up further. This is a regulatory thing, so hence you will be always uplink limited. So if you have to improve your coverage, you have to focus on uplink. And one way to improve your uplink thing is that you at least move your uplink into lower frequency band. That's called the supplementary uplink. From a scaling perspective, you can do carrier aggregation. That was there in 4G. Here we can scale up even further. You can go all the way up to 16 carriers. And there is an option for dual connectivity. So this dual connectivity has 2 uses. One is that you can connect to 4G and 5G or 2 5G radios simultaneously, improving your reliability. And then it allows you a mechanism to migrate from 4G to 5G. So both of these are helpful but your handset price is supposed to go up. So let's see how this whole thing comes out. So the RRC state, if you see in 4G, you had only 2 states, idle and active. We are adding a new state called inactive state. This inactive state, you don't discontinue your control information. So you are still registered with your phone, but you are not sending active data. So that's called the RRC inactive state. Even there are efforts during in MMTC type scenario where you can even send some small information in the inactive state so that you don't have to get into an active state. Whenever you move to an active state, you are burning up power on your handset, especially for MMTC case, IoT case. MMTC or IoT case, you don't really want to unnecessarily wake up and burn too much power, because the key requirement in MMTC is that you may be using a small battery and you still have to work for 10 years. So that's where the bigger difference is. Mobility, as I mentioned, we have this option of make before break. It's called tabs, which is provided in 5G, which was not there in 4G. there is an interference mitigation which is possible, so which was not there in 4G. See what was happening, say in Gujarat, we see some signals coming all the way from Oman if you are using TDD option. So this is because what we know as ducting. This is a scenario which happens in, so you get signals from Oman all the way till Gujarat. So this is an issue, but we couldn't ever find out where is the real, who is interfering with us, because none of the operators around you may be interfering. It's coming from a completely different country, which are not under your regulatory control. So to figure it out, you can do this cross-link interference and remote interference management. This came in release 16. Backhaul, as I mentioned, in 4G, it was only fiber or microwave. Here we have the fiber as well as IEEE, integrated access and backhaul. Sidelink is LTE based. So sidelink is used for vehicle-to-vehicle communication. By the way, I think I overshot the time. So if can I go for? I have few more slides. If you have time, I can continue, or I can stop it at this point.
Yeah, you can take another 5 minutes, sir.
Okay. So the HARC IoT, you have from a IoT perspective, only NB-IoT or LTEM was an option in 4G. Here we have NB-IoT or RedCap. RedCap is reduced capability devices. This would allow you to do much higher. It's used for say video, CCTV, etc. RedCap would be useful. NB-IoT and LTEM, it would be for a different purpose. Cyclic prefix, you had a normal and extended. Here, have extended only words. Extended cyclic prefix is needed to a larger. I'm skipping all of this, basically because I don't have time. So this allow full duplex MIMO. That means you can have horizontal as well as vertical processing, and skipping all of it, and then directly moving to the Indian part of it. What we did with 5G, it's called 5GI. I here is not India. It's basically improved, but within, so it's silent that way. We want to make it. So in India, I can be India, or outside India, it can be improved either way. So the whole thing started with the government starting the TSTSI on 7th January 2014. We worked, it took a lot of time before we understood all this process, because all of us were learning on the job, in the sense nobody had past experience working in ITUR. I had worked in ITUT, but I never worked in ITUR. So this was completely new. What we found out was many of the activity which ITUR was supposed to do was outsourced. So we learned it in a hard way. Then we found out that only requirements are done by ITUR, and then actual work happens in 3GPP. So we first standardized LMLC. This was in the last few meetings which we had to get it in. So we added a mandatory requirement called configuration C into IMT 2020. This was specifically to cover rural scenario in India, because in all developed countries, the rural scenario was high-speed train passing through the rural area, which means you basically have to handle 500 km/h and all that. In India, we don't have that scenario at all. In the sense, we are mostly concerned with basically doing lower mobility, but we need better coverage. So that's what we did. That was my requirement. Then 5G, we submitted an interim RIT, SRIT in 2019, got it approved in 2019, and this became a standard in 5GI following the step 8 process. So in addition to 3GPP 5G, 5GI is the only other 5G technology approved by ITUR till now. So this is quite an achievement from Indian side of all the academia who are involved with. And the key requirement, how it all started, was when we studied the distribution of Indian user, we found that most of them, this was from an NHI study, that moved at a speed lower than 30 km/h. So can we trade off speed to get a better coverage? there was analysis done. I have not shown it here. We found that if you plot the CDF of the distance of the radius of Gram Panchayat, we were getting an ISD. ISD is √3 times the radius of 12 kilometer. We went with assumption that it has to be higher, but because of all the politics involved, we couldn't get it into 12 kilometer. Eventually, had to settle down with 6 kilometer, and we couldn't put a ZH number to it. Yeah, we went ahead because 3GPP was not willing to do it. TSDSA also came out with this 5GI radio interface technology. And then we added that over and above the release 1516 so that we get an uplink coverage improvement of 40%. Right now, as we speak, this is being 3GPP has accepted this as a part of their technology. Now they are rolling it back into release 17. So roughly we did something which release 17 is doing already in release 15 timeframe. In the sense, so that's a good way. I think going forward we have to do much more in 6G, like what we did here. We also got some other icing in the cake, like better bandwidth utilization gains, better efficiency, reduction with this 5GI. These are the reference, and for 5GI, TSDSA reference others. So that more or less completes my session. If you have any questions, I saw some questions. How do you want to go with that, Madam?
Yeah, thank you, sir. Actually, we had a great session, and it was indeed a very informative session. Actually, there are a few questions in the chat window, so let us iterate through.
First, stop sharing. Okay, where is the? So let me start from top.
Yeah. Anyways, no issues.
In 4G convolution code used for, yes, yeah, okay, I missed that. There is a convolution code used for that. How NOMA was analyzed as part of 5G, and it was decided to continue with orthogonal multiple access. So NOMA was not considered as part of 5G. This is being seriously discussed for 6G. If any of you are interested, 6G work has started. So the initial technologies are being analyzed in ITUR. So the IMT 2020, which I explained today, there is an IMT 2030 activity which has started in ITUR. So if any of your colleges, etc., are interested, you should join TSDSI, and then jointly as India contribution, we can submit it to ITUR and 3GPP. So NOMA, as I mentioned, is not part of 5G because there was an analysis done and it was not found to be improving quite a bit from OFDM. Okay, so I don't know RSMA, so I think this again may come up in 6G. So the biological effect of 5G, okay, as I mentioned, we are not radiating most of the time, so we have taken conscious decision in 5G not to unnecessarily pollute the environment with RF radiation. That is one thing. The other thing is that these are all beam forming is there. So only if you are using your phone, you basically get some biological effect. Okay, and then the power levels are also lower because I get an improved gain, the array gain, and even it's basically because I have beam forming. Your ARP is better because your array gains are. The next question is, what is the promising area in 5G? 5G is more or less done and dusted. We are moving to 5G advanced and 6G. So in 5G advanced, AAML is making the first effort. So the idea here is that, see, one of the main, though I didn't cover in detail, the main problem in any wireless technology is the scheduler. How do you schedule the resources? How do you see? Basically, I mentioned it earlier. Like I decide today whether to take a road between Bangalore to Mysore, basically looking at the Google map, and the Google map in turn analyzes it based on all the AAML, based on all the user who are using that road between like Bangalore to Mysore, right? So similarly, can I do the similar thing with says you get the channel state information using CSIRS? You use that information, start training a model, and then can you use that information to do a better scheduling? So that is one area. The other thing is that can I sort of take out all the information and share it with end user on the data which I'm using, and that could be used for other part for doing a better like use case application wise analysis. That's related to AML coming into the radio part. The second aspect of it is related to relay, which I mentioned that right now, if you want to improve coverage, I can put a small cell with an IAP in between. Can that be moving? Can I move around? It's called vehicle mounted relay. Can I move around and do something better? So that means how do you handle the vehicle mobility? Other things are further improvements are being done on DMRs, MIMO. Can I scale it up further? That's in 5G advanced. But you are not allowed to change many of this, which I mentioned today in the talk. So that's all done and dusted. But you can do some improvement on the existing technology. If you want to look into a completely new technology, 6G is also starting. It's supposed to become all the new waveform, etc. You can start looking into it. Terahertz communication is one thing which I started happening. So what happens is you are basically losing characteristics of RF as you move to higher and higher frequency. So if you have studied optical communication, it looks more like an optical signal as you move from lower frequencies to higher frequencies. So your performance it's more like you are the laser pointer I was using, right? You are more like a laser pointer. So you can basically use something like mirrors, which is very common in DWDM, etc. The wavelength selective, etc. Can I reflect it? So it's called the RIS, intelligent surface. I think RI forgot. RIS is a upcoming research area, and a lot of work is happening around that. And then all this NOMA is one technology which can we go out of orthogonal thing? Can I use cell-free thing? Should we be still cellular, or can we move completely to a cell-less world? Especially because you are using larger frequency band. So a lot of promising areas in 6G, or if you want to improve the existing technology, that's another thing which you can do in this domain, which I explained till now. What about polar codes? As I mentioned, polar code was for control channel, especially for larger size. This was done basically because China was insisting on using it. That was one reason. And then it's very complicated code. While we simplified from turbo code to LTPC code, in the data plane, we are actually complicating, if you were to ask me, by moving from turbo code or convolution code to polar code in this one. We used to joke around telling that when this standard was there, that we are not a polar country, we are a solar country, so we don't need this code, but somehow it got included into 5G. So we have to leave it there. The other question is massive MIMO versus NOMA, which one is a better spectral efficiency? See, the initial study which was done in 5G during that time, I don't know that I've not read the full part. They found that massive MIMO is better than NOMA. So you can go and look back into that study and understand it. What are the waveform candidates? I mentioned NOMA was one candidate. So OFDM will continue to be there. So there are, I think, 3 broad categories which are being done. Bidirectional. So multiple options are, see, it's too early. Okay, so there is nothing like a candidate which has been selected. We are putting all the options on the table right now. So it is the meeting happened last 2 weeks back. So all options, every country is suggesting their own waveform options. So feel free to find newer. So One of the things, some field trial has happened is based on OMA. It looks a very promising thing, whereby you are rotating the phase, because as you know, when you are moving to higher frequencies, phase is a big problem. Phase, that's why if you see, I didn't explain it. There is something called a PTRS which was added. So phase tracking has to be corrected. So can I use phase to do the modulation? That's the OMA. So that's one option which has been tried by I think in China and showing very promising things. So that's one waveform which is also being considered. So nothing is decided. So candidate as on date. Do research on polar codes. Yeah, sure, you can do it. Yeah, I don't know whether you can improve it further going forward in 6G or even in 5G advanced. But yeah, it's right now used only for control channel. Is massive MIMO no more further? I think I answered it. Can you please enlighten antenna type parameter for forming used for FR2 also? Tell me the main vendor for 5G and beyond. Okay, 5G and beyond. We are just I work in a company called Tejas Networks. I don't know how many of you know. We are working on doing 5G right now. Beyond is, I think, yeah, we are a commercial entity, so we make products when we see a business opportunity. So we are not doing beyond. We have just started working on 5G. And there are many small companies which have come up, Samkhya Labs, Signal Chip, quite a lot of excitement with a lot of startups coming up. And most probably, you should have an ecosystem which would be able to take like Ericsson or Nokia from other countries. So you should be able to beat them up hopefully in another few years. Okay, my contact details was there in the last page. You can basically get it from there. It's basically jishnu@tejasnetworks.com. You can drop me a mail. How anyone can join TSDSA? You basically go to tsdsa.in. That's a website, and it's a very easy process for any academia to join. It's a very minimal charges. You can join TSDSA and like you can start participating. Thank you for the. So hopefully I answered all the questions. Any other question? I can just put on the chat. Thank you. What do you?
I think we don't have any other questions. Thank you, sir, for patiently answering the questions. So as we come to the end of the webinar, I request Mr. A.T. Kishore, founder and CEO, Vidya Sangha Technologies, Bangalore, to propose vote of thanks. Over to Kishore, sir.
Yeah, thank you, Dr. Uma. And Jishnu at Tejas, it has been a wonderful talk. And it's like 5G in IEEE, we have been talking from 2013 when LTE was just maturing. And then thankfully, God Almighty gifted India with the brains such as Professor Emeritus Aragaswamy Paulrajan, and in IEEE ITS, we have authors who are authoring some chapters on 5G. So it's a very important topic you have discussed. And there's a apex body giving guidance to Prime Minister, the current government of India, and 5G. I also am working with certain IIT on use cases of 5G for UAV. And as you mentioned about a mobile relay in between as like a base station concept, you also touched upon many things. One of them is about network slicing, focusing on one frequency range. Maybe quickly from quick response from you is that within a single frequency, will it not be possible to have different QoS, because QoS can allow at least some major assured forwarding, expedited forwarding, best effort at least some 10 different variants. So is it not possible within the single frequency block, you can have network slicing without going for a complete frequency allocated? You could actually
Very much,
answer.
sorry.
Another question is that the use cases of UAV for 5G that also combine into that, and then yeah, please, sir.
Oh, sorry. So for both the questions, the first thing on the UAV part, yes, it's an interesting thing. So the difference here is most of our antennas are directed towards ground. So with drones coming in, you have to have antennas directed towards the sky. And I think most of the like drones would be flying at a higher speed, so you would have to handle that aspect as well. So that's an interesting thing. There are still work happening on that, and a good research topic. Second question was on.
Yeah. Also, there is a 5G private network. If you could throw some light on that, Jishnu.
Yeah, so the private network, basically, yeah, this is the slicing and the private network is an important part in the sense, can I give some part of my existing frequency? So as you mentioned, I don't need a completely new band. Within the band, you can see when I discussed all the framing structure, within a band, I can have different subcarrier spacing within the same band. I can divide it into, one change I didn't explain is that uh, on a per symbol basis is what we have called the resource block, unlike in 4G. So at a symbol level, I can go ahead and do different things. So within a slot, I can have one subcarrier spacing. Another slot, I can have a different subcarrier spacing. That would mean that one operator, one slice can be given, one slot can be given to one operator, another one virtual network operator or a private operator, and then the other slot can be given to other. All this flexibility is built in. It's how we actually deploy it. Yeah, so private is a big opportunity which is coming up, and we, at least in Texas itself, we have seen few large. These are especially useful for large factories which use robot to move around things, or a mobility type environment is needed. They have asked us to build up network, and we are too early, but yeah, this is a good use case to work on.
Thank you. Thank you so much. And then, in fact, you have excited all our imagination. And as India is going, with Reliance and Airtel being two prime operators, maybe BSNL has to catch up. And also, I think there is a mood, as you mentioned, to move away from dependency on the one hand from the European or American, the traditional behemoths of manufacturing equipments like Ericsson's, Nokia's, and others, and also Huawei's and ZTE. So I think ITI ecosystem, there's an initiative to, MFI, at least from the BSNL point of view, they wanted to make the equipments, make in India 5G equipments. As you said, you are also participating in that. We look forward to hearing more from you on this. And wonderful talk, and it has been quite a refreshing and rejuvenating thought process. And you have touched almost a panorama of topics. Very, very nicely you addressed many questions, and I'm sure IEEE ITS, Dr. Param and Amber Bajpai and Dr. Uma and everyone, they've been doing great job. In fact, they started a year ago and did wonderful topics. This year, it's the 25th talk. 14th March, we have another talk. I think we are all blessed with great speakers like you, and looking forward to more research and interaction with you as a person, as also as a manufacturer. I have worked in Indian manufacturer ecosystem for telecom, like UTL India, and multinationals like Lucent, Alcatel Lucent, Nokia. So I very much resonate with the subject matter you discussed. Thanks a lot, and I hope all of the attendees have also enjoyed very much your talk, sir.
Thank you. By the way, yeah, we are also working with BSNL along with TCS and CDOT, and hopefully should when BSNL would be the Atmanirbhar network 5G. and hopefully we should be able to do it. We are working with many other partners, Deka Wireless, etc. So India is trying to put together an ecosystem under the one system integrator. There were other participants as well, L&T, TechM and all that. So this is a whole new opportunity where many small companies and jointly working under a bigger services company, which you used to be known, they are trying to put together a product solution, which hopefully starting with India, once it's deployed, stabilized, like to take it global. And hopefully all of us would be connected to a completely Indian vendor, Indian network, even starting with BSNL.
Thank you. Thank you once again, Jishnu.
Thank you. Thank you, one and all, for your patient listening the webinar. Have a great day. Thanks to the speaker as well. Thank you. Have a great learning ahead. Stay safe. Be healthy. Good night. So let us wind up the session. Thank you.
Thank you.